Okay, so so we're recording this for the first time. We'll see how it goes. We have a bunch of people in Leduc and the surrounding area. Some of the best DevOps engineers in the region can't make it in, and sometimes people don't want to go downtown. So we're going to try this out. Might be a little bit weird figuring stuff out, but that's okay. So your host, myself, Jared. I work for the City of Edmonton as a software engineer, and Grant.
Hi, I'm an engineer at DriveWise.
What are you, lead systems something?
Lead developer of advanced technologies.
That is dope. I knew it was a good one.
It's a pump-up name, yeah.
I like that. I like that. Okay, so agenda. I'm going to go through some welcome stuff, and we're making improvements to the meetup. I want to go through a few of them. Also, no pizza yet. I want to talk about that, and I want to get your guys' feedback on how we're doing sponsorship this time. I'll introduce our sponsors. Is that thing actually? Yeah, that's good. That's good. Jobs, if anybody's hiring or something like that. We'll talk a little bit about news. We didn't find a ton of news, so it'll be brief. But then we'll have two presentations, one from myself and one from Adam, who works at DigitalOcean. And then we're going to head downstairs to Mercer Tavern. So first off, recorded talks. Like I said earlier, this is definitely upping the level of complication for me. I'm pretty much at my, I'm a computer engineer, but this is definitely outside my pay grade. Sponsor swag. So I'd said before that I wanted our DevOps meetup to have the best swag of any meetup. So now I intend on making good on that promise. So the socks are all gone, which is what I expected. That is amazing. I'm going to see if we can get Elastic to send more socks, but there's a whole bunch of other stuff, beer opener, a bunch of stickers, and I think they have stickers for all their products. And those pens are pretty nice. Those are from the last one. Clio sponsored the last meetup, which was the social. So for those of you who don't know, last month we didn't have any talks or anything. We just went down to Mercer Tavern and basically just got drinks and food. So the other thing is we're trying something different for the sponsorship. So basically what we're doing is we're just connecting our sponsors directly to Mercer Tavern. And then whatever they're willing to spend is basically how much we get to eat and drink. So it's just a lot simpler for us organizing it. But I am looking for feedback. Usually for those of you that have come before, we'll have a bunch of pizza out, so you get to eat while you're watching the talks, which is kind of awesome. So depending on how people feel about it, we're looking for feedback. We can go back to the pizza way. Makes it harder to get drinks, to be honest with you. So that is some of the motivation. So our sponsor, Elastic. That's why we have all their swag out here. And always Startup Edmonton. Having this awesome space is amazing. So thanks to those two. My talk is also going to be on Elasticsearch and their new Kubernetes operator. Does anybody have any jobs? Hiring? Looking? Yeah.
I work for a company called Shobi. We are looking for backend Java senior developers.
Show me?
Shobi.
Like the streaming video?
It's an educational app. So I am not sure what you mean by streaming.
Oh, okay. All right. Anybody?
I think Shobi shut down.
Okay.
I made it. I don't know.
Did you?
Yeah, we worked on the team that made it.
Well, no wonder it shut down.
And then they shut it down.
Bastards. Any other jobs?
I believe DriveWise is hiring. We're looking for a mobile developer, which I know is not the right meetup here, but if you're interested, come talk to me. We're always looking for more people.
Okay, awesome. DriveWise. Anybody else hiring?
Yeah, I'll throw my hand up. So Intuit is always hiring. My team specifically is looking for a senior or staff level engineer in natural language processing space. I know there are probably a dozen openings Intuit and on various teams.
Nice.
It's a huge job for them.
Yeah.
We'll talk to them.
Cool. Anybody else?
We're hiring, but I haven't.
Yeah?
I'll say for the intro.
Okay, awesome. So the two pieces of news, I'm sure there was way more. Elastic Operator the beta for it was released. For those of you that don't know much about Kubernetes operators, I'm going to talk about it a little more in my presentation. And actually, so that's what I'm using in my talk. So the other thing, which is huge news, is VMware bought Pivotal for a few $1 billion. And a while ago, Red Hat was purchased by IBM for like 30 billion or something like that. So there's a whole bunch of stuff going on right now that VMware, they own Heptio, Pivotal, and there's another one. I can't remember the other company they own in this like containerization orchestration space. But they own like a whole bunch of awesome companies.
What is Pivotal?
Pivotal, so they make a managed Kubernetes service, basically. They have a few other things, like they have all these really weird software practices, like all their devs pair program, like 100% of the time. And they mentored a bunch of companies, like eBay apparently they mentored way back in the day.
JetBrains and IEE around
I don't think so. I think JetBrains is like a Ukrainian
what's,
company.
Who makes Intelligent?
JetBrains,
Oh,
yeah.
sorry, I'm confused.
I think they're Ukrainian or something, aren't they, JetBrains?
Yeah.
Something like that. But yeah, so Pivotal got bought by them for like 10% the price of Red Hat, and Red Hat owned, they bought OpenShift, which is Pivotal and OpenShift can compete against each other. So these are managed Kubernetes offerings, basically. So it's just interesting because they went for way, way less than Red Hat went for. And now VMware is huge in the orchestration and container space. So it's going to be interesting to see what they come up with in the future.
Question.
Yeah.
Since you brought up VMware, and I kind of like open source stuff. Have you heard of XCP-NG?
XCP-NG.
So it's a server virtualization.
Okay. No.
that,
What is it?
just like VMware Hyper-V.
Okay. Yeah. Yeah.
So you install it on a machine, and then you can virtualize servers.
Nice. Interesting. I've never actually heard of that. No.
Just a question. So.
Cool. Cool. Any other news that anybody knows about they want to bring to the top? All right. Moving on to the presentations. Okay, so we are going to have Adam from DigitalOcean. He is going to talk about best practices. So,
all right, thanks. Okay, I'm Adam Wolfe Gordon. As Jared said, I work for DigitalOcean. And I'm going to talk tonight about a tool that my team and I have built called Clusterlint to check best practices in Kubernetes. And I'm going to talk about what it checks, kind of how it works and why we built it, and what our plans are for it. And before we start, I wanted to mention that this is a very early draft of a talk that I'm doing at KubeCon in November. So if anyone has feedback after the talk, I would love to hear it. What were anything that went well or didn't go well. At KubeCon, I will have a co-presenter, so it'll be a little bit different, but this is an early start on the content. KubeCon is in San Diego. This one is in San Diego. Yeah, for those who don't know, KubeCon is the big Kubernetes conference. They do it twice a year, once in Europe, actually they do it 3 times a year. They do it once in Europe, once in Asia, and once in North America. So I was in Barcelona in May, and it's in San Diego in November. Yeah. So a couple of words about me and what I work on, first of all. I work for DigitalOcean, as I mentioned. For those who haven't heard of DigitalOcean, we're a cloud provider. We provide all of the kind of things you would expect out of a cloud provider, like virtual machines and storage, and managed load balancers, firewalls, et cetera, as well as now managed Kubernetes. I've been working at DigitalOcean since 2016. For most of that time, I worked on block storage. But in February of this year, I came over to the Kubernetes team to work on our managed Kubernetes offering, which is called DOKS or Docs. We like nautical themes since we're DigitalOcean, so Docs. And one of the big features that I've worked on for Docs is upgrades. So when you have a Kubernetes cluster on DigitalOcean, and there's a new version available, you can go in the control panel, click a button, and get upgraded. And I mentioned that because it sort of ties into why we built Clusterlint and why we care about best practices. So I'll come back to that in a few minutes. So the thing about Kubernetes is it's really, really flexible. And those of you who have used it probably know this. For one thing, it can run almost anywhere. It can run on hardware. It can run on VMs or under OpenStack, that kind of thing, on premises. It can also run in the cloud. You could spin up a bunch of VMs and manage a cluster yourself in the cloud. I'll get questions in just a second. It can use any of the many managed Kubernetes offerings, so Docs or Amazon EKS or Google GKE. There's others as well. You can run Kubernetes in every single Chick-fil-A and Target store in the United States. I don't know why they do it, but they do. And they run it on hardware there, I believe. In addition to running in lots of different environments, you can configure Kubernetes lots of different ways. There's lots of different network overlays, different storage drivers, different container runtimes, et cetera. And depending on how you configure it and how you're using it, you're going to manage it differently. You're going to do upgrades and maintenance differently. And if you are using a managed provider like DigitalOcean, then you don't really get to say how that maintenance and upgrade process works. It works the way we decide it works. But how you do maintenance and upgrades affects how you are going to deploy your workloads, because it has an impact on your workloads. So in other words, there's a lot of ways to get things wrong and have unexpected downtime for your applications. And what's fine in one environment, like if you're running on hardware, might not work well if you're running in a managed environment. So it's hard to define sort of general best practices. There's some general ones, and there's also some that are very specific to your environment and how you manage your clusters. And I'll get a question before I move on.
Is Kubernetes like, what do you call it, NGIX?
No, so Kubernetes is a container orchestrator, so you can run any kind of workload under it, including Nginx. So if you have an application and you want to deploy it into the cloud or onto a bunch of servers, Kubernetes is one way to do that.
Okay.
I've got a little bit of a diagram on the next slide that sort of explains that. So just as an example in Docs, here's how we do maintenance and upgrades and stuff. All of our nodes in Docs are virtual machines. We call our virtual machines droplets, so if I use the word droplet, that's what I mean. Your cluster has one control plane droplet, so the master up there, and an arbitrary number of worker node droplets, there. And if something goes wrong with we've decided that nodes are basically immutable. So once we deploy one, and we have automation around deploying them, of course, it's self-service, we don't really change them, and we don't try and fix them. So if something goes wrong with your master node, it's unhealthy there, we're not going to log in and fix it. We're going to create a new one and destroy the old one. And that just keeps our management processes really simple. It means that basically all of the master droplets are the same across the fleet of customer clusters. And we've got like thousands of customer clusters, right? So we can't customize each one. Same thing with worker nodes. If you have a worker node and it becomes unhealthy and you contact support and open a ticket about it, what they're probably going to tell you is click the replace button, it's going to get deleted, and a new node is going to be created in its place. And same thing for upgrades. If we want to upgrade to this new teal version of Kubernetes from the blue version that we were on, we're going to create a new master, delete your old one, and then one at a time, replace all of your worker nodes with new teal worker nodes. So that's kind of how we manage clusters under Docs. And when we released Docs and customers started using it, we pretty quickly noticed that this didn't match how customers were necessarily expecting maintenance to be done. Even though it's very similar to what other cloud providers do, it's just not something it's not necessarily the obvious thing. And it has some implications for workloads. So some of the things that this means are your node names aren't stable. When we delete a worker node and create a new one, the new one doesn't have the same name as the old one. So if you use that node name for scheduling, your workloads are going to be unschedulable after that replacement. Same with taints and labels that you set on nodes. If you have a custom label that you've set on a node and you're using it for scheduling, that's also going to go away after it's replaced or after an upgrade. We do have a concept of a node pool, and so we do provide a way to do that. It's not the same way that you would do it if you were running your own Kubernetes cluster. Same with node IP addresses. They aren't stable, so if you are using node port services and you point directly at your node, after an upgrade, that IP address has gone to some other virtual machine. You're not going to get your service. And same with file systems. If you are using host path volumes and you put a bunch of data in your Kubernetes cluster, after you do an upgrade, all of your nodes are replaced, that data is gone. So if you want to keep data, you need to use block storage volumes, and that will be persistent across upgrades. So we documented all these things after, well, some before and some after customers ran into problems with them. And of course, we've got playbooks for our support people to tell customers, how to do things properly. But we really wanted an automated way to warn people that they're doing something dangerous before they do something like replace a node and be surprised that its name changed. Or do an upgrade and be surprised that all their data's gone from their post pipelines. So we especially wanted this for the upgrade use case, and that's why I mentioned upgrades earlier. Because we replaced all the nodes, it's a pretty sort of disruptive operation, and we really wanted to let people know before they hit the final yes, please upgrade me button that they might have something go wrong if they've got something configured in a certain way. So that's why we built Clusterlint, and Clusterlint is a thing that exists now. It's at this URL. And I just pasted the blurb from the README on the slide, but basically Clusterlint is a linter, a best practices checker for Kubernetes clusters. And I'm going to talk a little bit about how it works. So we had a few goals for building Clusterlint. One was that we wanted to run against a live cluster, not against deployment manifests. This is a little bit different from how a lot of Kubernetes linters work, but we wanted to do that for two reasons. For one, you might not deploy everything from the same place, and your actual deployments might diverge from your manifest. So if you're just checking your manifests, that's not really the same as checking what's actually running in your live cluster. And the other reason is that we wanted to be able to run this tool automatically as part of our service offering, and we don't necessarily have your manifests, but we can connect to your live cluster. So we wanted it to be able to work against a live cluster, not against just a set of files. Number two, we wanted to be able to implement different groups of checks and have checks that were provider specific or environment specific as well as sort of general ones. So we wanted to be able to implement checks that were specific to docs and also have the ability to implement ones that are specific to GKE or EKS or any other kind of environment or hardware, Kubernetes, et cetera, and easily turn those on and off, select which set you want to run. And finally, since we want to run this as part of our offering, we wanted to make it really easy to integrate this into other code, call it programmatically, have it be a library, not just tied to a command line tool. So with that in mind, we started building Clusterlint. And when I say we started building it, I actually mean my summer intern started building it, and I reviewed a lot of code. So if you look at the contribution stats, Varsho wrote most of it. I wrote very little of it, but I did review all of it. So Clusterlint's operation is fairly simple. It connects to the Kubernetes API. And fetches basically all the stuff from Kubernetes. It says, show me all of the objects in the Kubernetes that you've deployed. Then it runs checks on them, and it produces a set of diagnostics, which are things that you maybe are doing wrong, things that you might want to change in your cluster that could have a risk. If you've worked with the Kubernetes API before, you know that fetching all of the objects takes a whole bunch of API calls, so we do them all in parallel, so they're fairly fast. We also didn't want each check to have to refetch the set of objects that it was going to look at. So for example, if you have two checks that both look at all the pods in your Kubernetes deployment, we didn't want them both to have to do that fetch. So there's actually no way for in our sort of API for the check to fetch objects. They have to work on the objects that are in memory. So that means the checks run pretty fast. The initial fetch is the sort of the slow part. These diagnostics can have a level associated with them, so there's some things that are more severe than others. They can also have a message, and they also tell you which object they apply to, and also the object that owns that object for something like a pod that can be owned by a deployment. Because you usually aren't going to fix something at the pod level, you're going to fix it at the level of the controller that is actually deploying that pod. The command line prints all the diagnostics standard out, either in plain text format or in JSON. And of course, you can also run this as a Go library, which is what we're starting to do internally. So it's not just tied to the CLI, but it does have a nice command line too. So just to give a few examples of things that it checks, some of these are really sort of basic Kubernetes best practices. They're common across platforms. So things like don't deploy bare pods, deploy something with like a deployment or a stateful set. The reason you do that is because if the node that a pod is running on goes away and you've just deployed the pod, it's not going to come back. You should use fully qualified image names, so use docker.io/nginx, not just nginx. The reason for that one is if you're using a container runtime other than Docker, it won't assume that prefix. So we currently use Docker in docs, but we've considered switching to containerd or cryo or some other runtime. And if we did that, then you'd run into trouble if you were deploying without fully qualified image image names. The next few that I have listed here are the ones kind of that I talked about related to our upgrade process. So not using the node name selectors, not using node labels and taints other than the ones that we provide. Not using close path volumes because they're going to go away when you replace a node. The next one is kind of interesting. This is also this admission controller webhook one is specific to our upgrade process. We discovered that a lot of customers had deployed these admission control webhooks that would prevent pods from starting during an upgrade, and that would break the upgrade process and actually just have it hang, and we'd have to go in and fix it manually. So this is one of the big ones that we wanted to warn people about before they upgrade is, hey, you've got this configuration that's probably going to cause your upgrade to go badly. A couple other ones that we do are unused resources. So we'll warn you if you've got unused persistent volumes or unused config maps. That's just kind of a nice tidiness thing. Not likely to cause any problems, but good to know about. And we also have a few really basic security checks. We suggest that people not use privileged pods just for security attack surface reasons, and that people implement pod security policies. So there's some really simple ones. Of course, sometimes we do bad things on purpose and break best practices. So we needed a mechanism for suppressing checks and having it not run on a particular object. Telling the tool basically, yeah, I know I'm doing this wrong, don't tell me. We have two ways to do this. One is by the command line or the API. You can tell it which checks you want to run and just not run the checks that you're not interested in. The other is via annotations. So every object in the Kubernetes API can have annotations, and we have this annotation clusterlint.digitalocean.com/disable checks, where if you say you are running a privileged container and you want to know about privileged containers in general, but you say that one's okay, I know about that one, you can put this annotation on and the tool will just ignore it. So I'll do a quick live demo and hopefully I'll be able to share it here. Let's see. I'm going to have to.
Yeah, I do.
All right.
I'm seriously contemplating what's going to happen when I run Clusterlint on all my Kubernetes clusters. Oh shit.
Yeah, so unfortunately, I don't think the live demo is going to show up on the stream, but
Have you tried to sharing your entire screen instead of
I can try that, yeah.
Might help.
Yeah, that's a good idea. Yeah, let's see what entire screen does.
I don't know what the issue is. I don't worry about it.
Okay, we'll be back to the slides in a minute, so yeah, we'll go with this one for now. So I've got a Kubernetes cluster with, and I've fallen off the Wi-Fi, that's why.
Ooh.
All right, let me get back on the Wi-Fi and then we should be good to go.
Hey, there it is. Okay.
All right.
Awesome.
So I have a Kubernetes cluster running on Docs with 3 nodes. There they are. And it's got basically nothing running in it right now. Actually, it has nothing running in it right now, except for the default stuff. Because I'm going to deploy stuff. I'm going to deploy I'm going to deploy this one pod that's in my badthings.yaml file. And I actually just copied and pasted this from the Clusterlint examples of things you shouldn't do, and just combined a bunch of them so to make it have some checks. So I'm going to do kubectl. I'm going to apply that manifest, and it's going to create the pod. If I do kubectl get all again, I should see that it's creating. It should be running soon. Yeah, it doesn't really care if it's running, but So here's the help for Clusterlint. It has 2 subcommands, list and run. You can list all the checks that exist. You can run checks. It can read your kubeconfig and connect to any cluster that's in your kubeconfig. I think we support all of the auth methods and everything that Kubernetes supports. So if you're using gcloud or something, it should work. But if it doesn't work, please let me know if you try it. So I'm going to tell it to run the checks. And it's going to find a bunch of problems. It's going to find a bunch of problems that are not related to the bad stuff that I deployed, that are actually just related to the managed pods that we run in clusters. That's because we haven't sort of cleaned up the stuff that we deploy yet to work with Clusterlint.
That'll make them feel way less bad.
Yeah, so I
Clusterlint
mean,
online.
things like your network, like your CNI driver,
Yeah.
those are always going to be privileged, right? And so we're going to warn that, hey, there's a privileged pod.
Yeah.
There's no getting around that. So that's one that we'll just suppress.
Right.
Other things like that. But at the very end here, you can see it's telling me that the pod that I deployed, pod/mypod, is using the default namespace, and I shouldn't do that. And if I scroll up, there should be some others. And I'll actually just grep for the ones that are related to the thing I deployed. So you can see it has a host path volume. It's using the default namespace. It's a bare pod, so it's going to go away if I get upgraded. And it can run as root. It's got lots of issues. So I have a manifest here where I fixed some of the issues. Actually, so what I have is a manifest where I've suppressed 2 of the checks. So I'm going to tell it, don't complain about fully qualified image. Don't complain about default namespace. I know that I'm using those. I'm bad for it. So I'm going to apply the version with the suppressions. And if I run Clusterlint again, I should see that there are fewer warnings now. It's still warning me about bare pods because I didn't tell it not to, but it's no longer warning me about default namespace. It's no longer warning me about the fully qualified image. So that's a really sort of quick demo of the Clusterlint command line tool. If we want to, we can also look at the JSON output. It's very ugly. You can, of course, prettify it with your favorite JSON prettification tool. The cool thing about the JSON output is it also tells you how long all the checks took to run in like nanoseconds, so it's not that useful, but you know, if you wanted to parse through it, good. Especially if we ever want to improve performance of Clusterlint, that will be helpful output for us. All right, with that, I'm going to go back to the talk. All right. So I have like 2 more slides here. I wanted to point out that there are some similar tools. Clusterlint is not the only sort of linter for Kubernetes. It's not the first, I'm sure it won't be the last. I think we are the only one giving a talk at KubeCon, so that's cool. I've kind of divided them into a few categories. At the top, I have the sort of manifest-based ones. So these are great for running in your CI/CD pipeline, making sure that the things you're going to deploy to your cluster look good. So kubeeval, Copper, and Kubelint are 3 examples. Copper and Kubelint are both kind of cool in that you can define sort of arbitrary rules for them to enforce. So if you have environment-specific things, you can encode them there. Or if you have, like, I don't know, arbitrary rules at your company about what you're allowed to deploy, you can also encode those. Kubebench is a security checker. It checks way more security stuff than Clusterlint does. It checks like all the theoretical things that you're supposed to do that no one does. But it's probably very handy if you want to make sure you're keeping up with security best practices. If you want a really flashy dashboard, there's Polaris. It checks both sort of workloads, workload health, cluster health, and also sort of best practices things like we check. And it has a really nice flashy web UI that shows all the stuff. You can explore it. And then there's Popeye, which is sort of a command line report card tool. It looks at what you've got deployed in your cluster and produces sort of like a letter grade and then also some recommendations. It's probably the closest thing I've seen to Clusterlint in terms of the way that it works. So it's, yeah, it's kind of a neat tool. The biggest difference between it and Clusterlint, I think, is Clusterlint is very sort of like bare bones. We want to be able to like parse the output really easily, use it as a library, et cetera. and also be able to have these groups of checks that maybe only apply to one environment. Popeye didn't really have that kind of concept. Finally, if you're using Kubernetes, I would love for you to try Clusterlint on your clusters. Let us know if it doesn't work. Let us know if there's surprising results. And if you have checks, especially environment-specific ones, if you're deploying to EKS or GKE or some other environment and you happen to know some things that are like dangerous to do there, please do add those checks and submit a PR. We would love to have all of those in there. We've been adding docs specific checks, but we'd love to have other environments as well. Especially, or even if you're using like Kubernetes on hardware. We have a team at DigitalOcean that runs Kubernetes on hardware, and they're going to add something to that. And that's it. Here's my email addresses. You can email me at either of those, and I'll stick around after to chat as well. I'm also on Dev Edmonton Slack. And I have 2 quick things to plug. Number one is my team is hiring. Other teams at DigitalOcean are hiring. Pretty much all our jobs are remote friendly, so if you want to stay in Edmonton and work for DigitalOcean, you can. If you go to this jobs.adamwg.com, that will link you to the DO careers page, and it will put my little referral link in so that if you get hired, I get some money. But I mean, feel free to like apply through other means as well if you don't want me to get money. And also feel free to ask me questions if you see anything that you're interested in. I'm happy to chat about DigitalOcean and what it's like to work there. The other thing I wanted to plug is Hacktoberfest is coming up. This is something DigitalOcean puts on every year, where if you make some number of pull requests to public GitHub repos during the month of October, we will send you a t-shirt. So if you go to hacktoberfest.digitalocean.com, you can see all the information about that. And we are going to be planning a sort of Hacktoberfest party locally in Edmonton sometime in October, so keep your eyes open for that and join us for that. Yeah, that's about it. If people have questions, I'm happy to answer questions. I'm also happy to chat later about questions. Yes.
How extensible would it be in terms of adding your own checks? Would you have to, is there a way to do that, or would you have to submit a PR to check that you think?
You would have to submit a PR right now. We've talked about using like Go plugins, so you could write like a module and have it loaded, but we haven't implemented that right now. Right now they're all just in there. But you can put them in their own group and turn them on and off. So as long as it's something that's like sort of commonly used, or useful to someone other than like yourself. Yeah, it's yeah. So it's very flexible, but they are all in code. There was a question.
Do you provide already produced binaries or not really?
We don't at the moment, but that is something we should set up. If anyone wants to write GitHub actions for that as a Hacktoberfest pull request, that would get you like halfway to a t-shirt.
Wait, we can't split it up into 5 PRs.
You can split it up into 5 PRs if you want. Yeah.
By the way, the Hacktoberfest t-shirts are usually amazing. Like,
Yes.
Do the PRs have to be accepted to get that hacked over?
No, they have.
I think
They
do
they just have to be not marked as spam.
Okay.
So.
There's your problem.
So the thing is okay adding spaces or that?
Yeah. README fixes.
Yep. Region fixes are great. All right. Thanks everyone. Yeah, that's all.
Okie dokie. So as I mentioned in the news, Elastic has released an Elasticsearch operator. So basically, the way this is going to go is, so I introduced myself earlier, but I work for the City of Edmonton. I do lots of stuff on Kubernetes. It's kind of an open secret that this meetup, it's the DevOps meetup, but probably like 60 or 70% of the talks are Kubernetes related. And I just think there's a lot of hype around it right now, and a lot of people are really into it. And so this is also going to be kind of related to that. But the cool thing about Elasticsearch and Elasticstack is that it is related to other more traditional ops types of things like logging, monitoring, alerting, and stuff like that. Did you guys use any Elastic stuff at Dragwise?
We have Graylog, which has Elasticsearch underneath.
Right, okay.
That's about it.
Yeah, so it is pretty commonly used, and you'll see that a lot with Elasticsearch, where there's something sitting on top of Elasticsearch. But I do a lot of this kind of stuff at work, Kubernetes and Elastic, and building applications on top of them. So basically, I'm going to talk very briefly about Kubernetes. We did have somebody just before this who literally builds Kubernetes explain it to you. So Adam, you probably are going to do a better job than me anyways. I will talk a little about operators. They're definitely an interesting thing for Kubernetes, super, super valuable. And then I'm going to talk about installing Elastic Cloud on Kubernetes, which is their operator, Elastic's operator. And the rest of it is actually just a demo. So basically, I'm going to be stepping through these things, going back and forth. I might skip ahead a little bit, run some commands, just because a few of them take a while. We're going to be indexing a whole bunch of documents. And then at the end, I will show you a demo, an early version of an application that's built on top of Elasticsearch's operator. OK, so first off, Kubernetes, very briefly, it runs containers, essentially. So this is a new paradigm for orchestrating containers. It's the dominant container orchestrator. So a lot of people, when you start working with containers, you're playing around with Docker, you think, you got the world. But it kind of turns out you need something to run those containers, and it's actually pretty complicated. And for me, I think Kubernetes feels more complicated than Docker does on its own. So there's the lion's share of the work, I feel like, with containers is learning how to run them, basically. So I'm going to be running everything in Google Kubernetes Engine, but one of the cool things about Kubernetes is that it's very flexible and it runs basically everywhere. So another thing that's pretty awesome is you can run Kubernetes locally. Docker now ships with a local version of Kubernetes. The community used to use something called Minikube. And I don't know what everybody here uses for Kubernetes locally on their local machine, but I've switched to using Docker's Kubernetes. Pretty awesome. OK, so operators. So historically speaking, Kubernetes was typically used for stateless applications. So the idea is that the code is disposable. And actually, you kind of touched on it before, Adam, where things, not just your containers, but in the case of DigitalOcean, they're nodes, so the VMs or the droplets that it runs on, they disappear all the time. And so originally, people were kind of just running these stateless apps. So if you're connecting to some data store, that's how you store your data. But the operator pattern is really trying to solve that storage issue that Kubernetes has had. And it seems like the experience is very, very good from the operators I've used. So it helps you with way more advanced storage operations than what you would historically get with something like Helm. So in the past, I've deployed Elasticsearch using just kubespec files and also using Helm. But the problem is there's so much that goes into storage appliances that isn't captured in something like that, like going from version 6 to version 7 of Elasticsearch, for example. So I think between 6 and 7, they got rid of types in Elasticsearch, which for those of you that don't use Elasticsearch, you can kind of tell how massive that is, just getting rid of types. It is crazy. Scaling cluster capacity. So that's another thing that operators can help you with, is auto-scaling, configuring your cluster, and backups. And there's a million other things, and it depends on what you're actually going to run. But for this presentation, I'm going to talk about Elastic Cloud. So basically what I'm going to do is I'm going to install what are called custom resource definitions in my cluster. So it's downloading a kubespec file. It has custom resource definitions, which for those of you that have used Kubernetes before, resources are things like services or deployments or pods before. So one of the interesting parts of operators is that they allow you to add on to the Kubernetes API. And so you'll see I'm going to run some commands later. An operator, if it has its own custom resource, it starts to look like it's a first-class Kubernetes citizen. So kubectl get Elasticsearch instead of just treating Elasticsearch as a stateful set or looking at the pods for Elasticsearch. OK, so this is kind of confusing, but so Kubernetes is a cluster. There's a whole bunch of nodes, a bunch of droplets or servers. Elasticsearch also calls its platform nodes or cluster. So this is a cluster on a cluster. I hope you like clusters. So I am going to set this up real quickly. And I am going to run this. OK. So basically what this is doing here is this is setting up the single node. You can see that here. So that's the single node Elasticsearch cluster. So for anybody that's used Elasticsearch before with kubespec files or Helm charts, this is like way, way more simple. than using those. And one of the really slick things with the Elasticsearch operator is it comes out of the box with TLS. And so it's straight away you get HTTPS out of the box for free. Sometimes that's nice and sometimes it's not. What that means is for people running that in their Kubernetes cluster, internally everything is encrypted. And depending on how you run your clusters in Kubernetes, sometimes you'll have like a full trust system inside your cluster. I think the pros probably have a zero trust system where you're exchanging certificates and stuff. But it is, let's be real, it's pretty common to have trust between your services inside a cluster. And in that case, oftentimes what you'll see is traffic that comes into your cluster terminates the secure channel at the boundary of your cluster, and inside your network, it's all unencrypted. So it's pretty slick that Elastic comes out of the box with a certificate and just manages that certificate for us. This stuff down here is actually me dealing with that. So I'm going to index a bunch of documents later, and we need that certificate so that we can trust it. So it creates an admin user for us. This is me downloading the password, basically. I'm going to skip ahead a little bit. So rather than setting up an ingress for this temporary cluster, I'm going to forward the port that is pointed to Elasticsearch. And I'm going to forward that to my laptop. Get our self-signed certificate. So this is the certificate that I talked about before. Depending on how you want to build your cluster out, you could make some changes. So for example, the demo I'm going to show later, I replaced their certificates with the City of Edmonton's certificates. And I think it is time to check on our Elasticsearch cluster. So like I'd mentioned before, so you can see here, Elasticsearch is treated like it's a standard resource. It's actually extended the API for Kubernetes. And they have a whole bunch of different things they've added, APM server and Kibana, and I'm not going to get into too many of those, but this just demonstrates that it starts to kind of look like it's a part of Kubernetes. One cool thing about Elasticsearch that I really like is basically all the functionality of Elasticsearch is exposed through a REST interface. So you can curl or integrate with it to your heart's content, which is really nice. So just to show you what it looks like to get a health check for curl. So we are green. And you can see here the certificate that I downloaded, we are actually passing it in. OK, so we have a CSV. It's got a whole bunch of documents in it. In this case, this is council reports. So I got it from some of the data scientists that work at the city. And some of these, so this is just the fields in the CSV. So basically, this text one is massive. The other ones are fairly small. So I think we have about 1,000 in CSV. I built a command line interface for uploading CSV files to Elasticsearch so that you can search them. And I'm going to use that to import our data. Okay. That is, Oh, sorry. I know what I did wrong. Yep, that is it. I'm not inside my virtual environment. OK, thank goodness. OK, I see a connection here. So I'm going to go back and talk a little bit about forwarding ports. So basically, you have services, which is a resource type, just like Elasticsearch now is. And it's often difficult to, or I don't know about difficult, but it can be confusing to figure out how to get access to your pods. And configuring that is a really critical part of running a successful Kubernetes cluster. So one of the handy things you can do is you can forward a set of ports on different pods or just a single pod directly onto your local machine. And so that's exactly what we're doing here. This Elasticsearch cluster is not accessible to the internet. It's just running in GKE, which has a pipe open to my laptop. So you can see we indexed about 1,000 documents. Took about 10 seconds. So let's look at our index. Okay, it is saying it's yellow, but it does have a bunch of documents in it, 984. So that is good. Let's see if we can actually search on it. We may not be able to just because Elasticsearch may still be doing some stuff behind the scenes. The operator, as far as I can tell, the operator is doing a whole bunch of stuff that I used to have to do on my own when I was running Elasticsearch clusters. Okay, so you can see this doesn't look super pretty, but I'm going to show you in a second an application that's built on top of it and how you can make it look a lot better than that. But this also demonstrates what I'd mentioned before. So Elasticsearch exposes all of its services as a REST endpoint. Okay, so basically it informs you the number of hits, and it also gives something called the score. So basically, on a simple search in Elasticsearch, you're gonna match the term that's passed in against a whole bunch of documents. So that's those council reports that we indexed a second ago. And this is what our document looks like. So this was the CSV a minute ago. Now this resides in our Elasticsearch cluster, which sits on top of Kubernetes. So you can see here I've truncated the text. This portion of the document is often massive. So I think some of them, I don't have that as part of this data sample, but some of the documents were like 15 megabytes on their own. I'm going to show you in the example application here. Okay, I'm going to turn this down a bit. Okay, what should I search for? This is just so you know about the data. This is basically what council is, what reports are being given to council. So the things that, I don't know, their day-to-day, what they're concerned about. So it should be indicative of where money is being spent roughly.
Scooters.
Scooters. Also, there's a bug in this. It breaks if there's no documents that match. Fortunately, they talk about scooters. Bylaw amendments for active transport. I'm sure that's some nice light reading.
Is this information available to the general public?
Yep. Yeah, so this, we pulled this from, I think it's called Sire. So there's a platform that everything the council does. There's also video, I think, of all the council meetings. And basically what we did is we extracted all the PDFs, the text from all the PDFs, made that CSV, and then I uploaded it here.
So you're kind of making all this information easier for the public to...
Yeah, so the idea is, and actually, so the big data thing at the city is open data. And they have a huge amount of data in there. And actually, one of the ETL experts, so that's like extract, transform, load, I guess. So that's data in to data out. And we could have done it actually, I found out afterwards, a lot more easily. I didn't need that Python script at all. You can just use an ETL pipeline to take it straight from the source and put it straight into Elasticsearch. But anyways, so our open data guys is the ETL wizard. And he's really interested in setting up a pipeline between open data and our Elasticsearch cluster to index a whole bunch of different data sets and basically discoverability, right? That's what you want, is can you basically bring the most interesting stuff to the top. Council reports, maybe not always the most interesting thing, but so one thing I wanted to point out here, so before when you were doing the simple search, it returns all of the documents. That's actually returning a lot of information. So this is called text highlighting right here. You can see it's actually just the italicized portion that is being highlighted. But basically, this document is probably massive. Like, let's open it up. Okay, it's not huge, but all right, fair enough. But yeah, so it cuts out a whole bunch of that. So one really handy thing, this is basically perfect for applications, right? Say you index like a 15 megabyte document. When a user searches on it, you don't want to have to send that 15 meg document to the client, right? You want to be able to figure out the relevant portions of that document. And this actually came out of the box with Elasticsearch. So that operator, what we're doing is a little different than what I'd showed you guys before. So this cube spec back here, Ours is a little more advanced than this, but not much. So we have more nodes. Instead of setting this stuff up for using their self-signed certificate, we're using the City of Edmonton certificate, and that's basically it. So another thing I wanted to show you guys is a timeline. So this is interesting. I think longer term, one of the things that the data scientists were interested in is, can you correlate the things that people are talking about with what's actually happening? So you can see scooters, that makes a ton of sense. Those dates are really, really small, but that starts, I don't know what they're talking about here or here. What scooters were they talking about in 2011? Huh. But you can see a clear spike over here in 2018. Early 2018, they started to worry about it. So one of the things they want to do is index a whole bunch of like tweets or something and see how many people are tweeting about Lime and scooters and correlate that against the action of council actually getting reports fed to them that includes, you know, Lime and scooters and whatever the other one is, Bird. So yeah, that's it. That was made by one of the data scientists at the City of Edmonton, Roman Eisner. And yeah, that's Elasticsearch on Kubernetes using the Elastic operator. So this is one of the really slick ways you can use operators. There's a million other things. So if your company is using Redis, if you're using a document database, you might be able to run the document database in containers, for example. Or, you know, Postgres or whatever. And it can handle a lot of complicated stuff. I haven't gotten super deep into some of the stuff the operator can do. It's primarily just orchestrating it early. But long term, it can run things like upgrades and notify you of viability of upgrades and stuff like that. So I actually have this presentation on my GitHub. You can use it to set up a local Elasticsearch cluster. Elasticsearch actually uses a lot of resources. Text search in general uses a lot of resources. So feel free to check that out. Yeah, questions?
Could you show what the operator config file looks like?
So Elasticsearch's config file? Okay, let's see if we can find it. We might be able to. Let me try.
Probably scary.
Describe Elasticsearch, maybe? Actually, you know what? Yes, there is a place to look for it. Let's see if this works. Oh yeah, there you go. So the complicated thing about it is, I only showed Elasticsearch here, but Elastic, the company, has a whole host of products. They have like performance monitoring. They have Kibana, which is a dashboard and visualization tool. They have all these beats where you can integrate with a bunch of data sources and stream it all into Elasticsearch. And they got a million other things. And every single one of those things basically has a resource. So this is only one of them. This is Elasticsearch, the one we just used. Oh, actually, this is the specific operator that I used. The other thing we could do, actually, is look at this guy here. So this is the kubespec file that creates all of the resources. So you can see there's the custom resource definition for APM server.
Can you scroll how many lines there are? Just like,
Oh, wow.
That is actually a large, they do a lot of stuff in here, a large service definition. So this is the actual, interesting. So this
do
is,
you know if this like also includes like resources like Elasticsearch nodes, or this is just the operator that have permissions to create pods and all this stuff?
so this actually runs all of it creates the stateful set that runs the pods that are your Elasticsearch nodes, essentially. So in the case of this, we created a single node Elasticsearch cluster. At work, ours is a 4-node Elasticsearch cluster. And I've run into a few issues. I've run into evictions and stuff like that. So for those of you that have used high resource pods like Elasticsearch, you may run into this running it on top of Kubernetes, but basically Kubernetes is built to ensure that you don't steal all the resources from other applications. And so for sure with Elasticsearch, because it's so resource intensive, I think I have it set to 4 gigs per pod, per node of RAM. So yeah, it's been very interesting. It's still in beta, so they're definitely ironing out some stuff still. But yeah. Any other questions?
Can you link your cluster?
Yeah, in front of us. I'm gonna do that in like a locked room and then never report the results. Probably gonna go home and like make sure nobody else has any accounts that have access to my clusters so that they can't independently verify the results I report using Kubelint. I'm Kubelint at the City of Edmonton, so you don't need that. You don't need that shit, come on. It's gonna be a train wreck, I'm not gonna lie.
Do you know if those operators actually help you with like essentially managing the Kubernetes state? Like in a sense, if you have a cluster of multiple nodes and you deploy it, essentially the Elasticsearch would deploy those nodes, right? So then in case of issues when you want to scale your cluster or upgrade it, usually when you install software there would be have like a system services or daemon sets or so on that make actually removing the node or evicting everything kind of problematic,
Yep.
right? So is the operator kind of supposed to help you, or essentially you deploy it and it's like, oh, how do I even move it now?
So the dream of operators, the reason they're called operators is because they are trying to replace ops people. So that, you know, they're trying to take everybody here's jobs, basically. And so in the case of this here, so you can see version. The idea is basically you have custom resource definitions, you have operator, but you have a controller that receives all of these documents that you're sending to Kubernetes. So if you were to change this, it's the same style of experience where you're describing the state you want everything to be into Kubernetes. Everything inside the magic box that is Kubernetes is supposed to make it so that that state comes true. And like you've mentioned, that's extremely difficult with state. If you're upgrading, like in the case of from 6 to 7 with Elasticsearch where they remove types, I'm fairly confident that it is impossible currently to write code to do that in all cases without human intervention. But that is still the ideal that you're moving towards with operators. And so if I were to change this from 7.2 to 6, the idea is that that would down version and manage that all for me. Or probably more realistically, bring it up to 7.3, which I think is coming out soon. And yeah, in the case of Elasticsearch, it's a little different because Elasticsearch runs on a whole bunch of different things. Kibana actually has an upgrade assistant, and I would expect to see that basically forever. I don't think operators are going to solve all the problems, but that is actually the goal, right? You're describing the state of the cluster to Kubernetes, and it's making it happen behind the scenes. That's like the dream of Kubernetes, essentially. So, any other questions? All right. Well, thanks for coming out, everybody.